Example 9 is a very common and popular question in exams, so it is very important that you fully understand what example 9 is all about. Find the range of values for p for which this quadratic expression is always positive. Now what does it mean to have this quadratic expression to be always positive? Well, very simple. It simply means that this quadratic expression p over 2 plus 2 is greater than 0. Alright, now this is when I want to draw attention to the different types of manner that they can rephrase this question. This same question can be rephrased into a question like this. Alright, find the range of values of p, alright, for which this quadratic equation is greater than 0. They mean the same thing. Alright, so I need you to be very clear whenever you read the question and you make sure you understand what the question is talking about. The next thing I want to draw attention to is here. Alright, always positive. Okay, now it is very important to know this. Always positive does not mean never negative. Okay, always positive is different from never negative. Now, what is the difference? Now, it is a very small difference, but it is different, and that is what you need to know. Always positive would be, well, it has to be greater than 0. No other way, no two ways about it. It cannot be 0 because 0 is neither positive nor negative, so it can't even be 0. Okay, so it has to be always positive. But never negative includes 0. Never negative means it can be equal to 0. Alright, so there's only one very minute difference between the term always positive and never negative. Okay, never negative includes 0 while always positive does not include 0. Okay, now the reverse is true, meaning to say always negative and never positive. Okay, it's the same kind of concept, same kind of thinking. Alright, so let us come back to our question here. So we're supposed to find the range of values of p for which this expression, this quadratic expression, is greater than 0. Now what does it mean? I mean, what are you going to do? Okay, now many people tend to do it the wrong way, okay, which I'll explain later. Alright, for now I'll just teach you what is correct. So what do you know about this quadratic expression here? Now that this has to be a happy face curve, right? It is a positive x squared, and therefore it must be a u-shaped curve like this. Okay, but what happens here is that this happy face curve is always positive. Alright, what does it mean? Well, what it means is that it graphically, to be always positive, this happy face curve will have to be hovering above the x-axis all the time. Well, it can't look like this, alright, because if it looks like this, if it were to cut the x-axis at 2 points, then there will be some parts of the curve that is not positive. But you know that this can't happen because the curve has to be always positive. So in order to be always positive, it must be hovering above the x-axis like this. And when it is hovering above the x-axis like this, it means that there is no x-intercept at all. When there is no x-intercept at all, it means that there's no real roots, and when there is no real roots, it means that your b squared minus 4ac would be less than 0. Okay, b squared minus 4ac, your discriminant will have to be negative because there is no real roots. Okay, so let us continue. What is our b squared? B squared obviously will be a p squared minus 4a. A is 1, and of course ac, c will be p over 2 plus 2 will be less than 0. So working this out, we'll get p squared minus 2p minus 8 will be less than 0. Okay, then of course up to here we know what to do next, don't we? Alright, we'll factorize. So you get p minus 2 and of course p plus 2 less than 0. And what's the next step? Okay, we have to sketch. Okay, so we have -2, +4, and we want the parts of the curve to be underneath the x-axis, be negative. Okay, so we know that our p-value will have to be between -2 and +4. Alright, so this is our p-value. Alright, does it look easy? Okay, yes, it is actually quite easy to understand, but let me tell you what many people would like to do. Okay, many students make this same kind of mistake. What many students tend to do is this. Well, they say, okay, that this quadratic expression is always positive, so they copy this. Alright, they go, yeah, I know this. Okay, but they do not, okay, what they don't do is that they do not think graphically what this implies. Okay, they do not think of the curve having to hover above the x-axis. So what they did, by way of convenience, will be this. Okay, since this quadratic equation, this quadratic expression has to be greater than 0, therefore, okay, you know, b squared minus 4ac will be greater than 0, isn't it? I mean, come on, it's greater than 0, then this will be greater than 0. So they will work out everything as per what we have done here. The only difference is the sign. Okay, instead of having less than 0, they have greater than 0, and therefore their answer, okay, even though they draw the curve correctly, intersect at the correct place, okay, and they will identify the wrong parts of the answer. They have p greater than less than -2 or p greater than 4. So they will leave this as the answer and they will get 0. Okay, now this is entirely wrong. This is wrong because it doesn't make sense. Alright, because you must understand that for this quadratic expression to be always positive, okay, the U-shaped curve, the happy face curve, has to be hovering above the x-axis at all times. When a U-shaped curve like this is hovering above the x-axis at all time, it is always positive. It will not have any roots, and when it will not have any roots, your b squared minus 4ac must not be more than 0. So this is utter nonsense. This is wrong. Alright? So then you may have another group of students who like to, you know, be the smart Alex. So they go around and say, okay, so this is actually quite easy, isn't it? I mean, you know, so when you see the sign being positive, then your b squared minus 4ac will be negative. I mean, you just change the sign. Doesn't it work this way? I mean, come on, it'll be correct. Alright, sad to say, good to know. Again, if you are trying to think of it that way, you will be pleasantly surprised again. Okay, it is still wrong. Alright, I'll show you one more example why would that be wrong. So let us move up a little so I make some space for the next example. Okay, now let's say now we have this negative x squared quadratic expression here. Now this negative x squared quadratic expression here has to be less than 0. Okay, now so let us try to see if the logic of the reverse mentality works. Okay, the smart Alex way. Alright, so well, okay, so it's simple, isn't it? So b squared minus 4ac, in this case this is less than, so you use opposite sign. Okay, you have more than, greater than 0, so you have p squared, alright, minus 4ac will be more than 0. And of course, I mean, working this out shouldn't be a problem. They can work this out very easily. But let us now take one step back and think about this. Does it work? Okay, so let us first try to figure out the kind of concept, the kind of thinking that we all must think of. Okay, first of all, this is a quadratic curve that is n-shaped because this is a maximum curve, right? So this n-shaped curve has to be always less than 0. So for this n-shaped curve to be always less than 0, it has to be below the x-axis at all times, isn't it? It has to be always be below the x-axis to be always negative. Now when it is always below the x-axis, it means that there is no x-intercept, right? So if it has got no x-intercept, what do you know about its discriminant? Well, the b squared minus 4ac will have to be less than 0 and not more than 0 as what you would otherwise think. Okay, so again, this is wrong. So the conclusion, what can we conclude, is that sometimes, okay, in a maximum curve type of question, when you follow the sign, well, you get it correct. Okay, now in other times, when you're dealing with a minimum curve, okay, a happy face curve like this, and if you were to follow the sign, you get it wrong. Alright, so that is why some students never learn their mistake, because half the time they get it right, half the time they get it wrong, and they have no clue on why are they right and why are they wrong. Okay, so obviously I don't want you to learn it this way. So please be very, very careful with this type of question. Always think graphically what the quadratic expression or inequality is all about. Okay, so let me just repeat one more time, okay, so that it will stick to you. So always remember that when you have a quadratic equation like this, that is always greater than 0. What it means is that it has to be a happy face curve, and it must be hovering above the x-axis, and therefore when it hovers above the x-axis, it means that the b squared minus 4ac has to be less than 0, because there's no intersection with the x-axis and there's no real roots. Okay, so likewise for maximum curve, alright, for a maximum curve to be less than 0 at all times, that means to say a maximum curve that is negative all the time, alright, it has to be below the x-axis at all times in order to be negative all the time, right? So therefore, if it is below the x-axis, it has got no x-intercept as well, and therefore the b squared minus 4ac must be less than 0 again, because there's no intersection, there's no real roots. Alright, so the bottom line, in summary, what is the most important thing that you must take away from this example would be never just simply follow the sign. Okay, you don't simply follow the sign because they give you the sign. So please think about it, alright, and before you work out your b squared minus 4ac, before you decide whether your b squared minus 4ac should be positive or negative.